All right. It's okay. Welcome back, my NextGen family. We are going to go through the second part of this paper, October-November 2024, paper 1-3. Okay, we're going to start from question 7. If you want to watch back the previous one, the first 6 questions, you can watch in the previous video. Okay, let's go to question 7. Given that y equals to x cubed ln x, find dy over dx. Okay, what do we need to find? This is a product rule. Okay, what product rule? We will split this into u and v. U is x cubed, v is ln x. U prime, 3x squared, v prime, 1 over x. Okay, try your best, remember, to always write it down like this first so it's easy for you to check back. I know some of you all will straight away just write into the formula, which is not wrong, but this is the way that I prefer to do. Okay, so we're going to do a product rule here. Product rule is uv prime plus vu prime. Okay, uv prime, x cubed times 1 over x plus ln x times 3x squared. Okay. From here, okay, actually, okay, by right here, you whatever that you can simplify, you simplify. But remember, every time when we do product rule or quotient rule, normally if they never ask you to simplify, you all don't need to go and simplify so much. Okay, unless the following question requires you to simplify it. Okay, but for this one, the most you do is you just cancel these values out. Okay, so x squared, then don't put 3x squared behind. This one 3x squared, you put it in front here. So x squared plus 3x squared ln x. Okay, question B. If the word hence here means you will use the previous question, find this integration giving your answer in the form ln a plus b, where a is an integer and b is a rational number. Okay, integer means whole number, positive or negative. B is a rational number. Rational can be whole number, can be fraction. Okay, the main thing is fraction. So this question is called a reverse differentiation, where we integrate from the answer in the previous one. So part of this, you see here, 3x squared ln x. That means when we integrate this, we'll go back to the question. So we will start with the question A, integrate the answer. So integrate x squared plus 3x squared ln x dx. We'll get back to x cubed ln x. Okay, x cubed ln x over here. Okay, let's rearrange it first. The one that we want is just this part here. All right. Okay, sorry. I want to also, because this is a definite integral, let's put the 1 and 2. Okay, 1 and 2. So that means when we integrate this, we will get this over here. This one, don't need to go and integrate already. Okay, we will split these two up because we only want this part. So plus and minus, you can split it up. So we will write it like this. Integrate 1 to 2 x squared dx plus integrate 1 to 2 3x squared ln x dx equals to, okay, this one you can sub it in, but later only we sub in lah. Okay, ln x 1 to 2. Okay, then this one, don't go touch it. We want to integrate this part only. X squared will become x cubed over 3. 1 to 2. Okay. Okay, yeah, you can bring it to the right hand side if you want. This one x cubed ln x 1 to 2. Okay, we sub it in. So we sub the 2 and 1 here. This will become 8 over 3 minus 1 over 3. Okay, or perhaps maybe I make it a bit more a bit neater, the working. So we bring the x cubed, that one, to the right hand side first. 3x squared ln x dx equals to x cubed ln x 1 to 2 minus x cubed over 3 1 to 2. Okay, from here, we sub in the 1 and 2 into the equation. This one will be 8 ln 2 minus ln 1. Okay, ln 1 will become 0 minus 8 over 3 minus 1 over 3. Okay, this will become 8 ln 2 minus 7 over 3. They want it in that form, ln A plus B. So ln A plus B will be ln 2 to the power of 8 minus 7 over 3. Ln 2 power 8 will be ln 256 minus 7 over 3. Okay, this can be a potential paper 1 question. Okay, so just be ready for it. Can do without calculator. So all the exact value type, you can do this in paper 1. All right, question 7. If you can do this, can you type 7? Any question? Please type your question down. Okay, easy. Now easy already. Okay, very good. All right, okay, let's go to the next one. Question 8. The straight line y equals to 2x plus 1 intersect the curve of this equation at the point A and B. The point C with coordinates 21 over 10k lies on the perpendicular bisector of AB. Okay, find the exact value of k. First thing that we want to find is, we want to find perpendicular bisector of AB. Okay, before we find perpendicular bisector, we want to find what is the point A and point B first. Okay, so let's find point A and B. Okay, we need to do a simultaneous equation. So y equals to 2x plus 1 and y equals to, y plus xy plus 3x squared equals to 15. Okay, we've got equation 1, equation 2. Okay, we're gonna sub 1 into 2. Okay, pretty long, this question. Not very hard, but just very long. Okay, sub 1 into 2, we will get 2x plus 1 plus x, 2x plus 1 plus 3x squared equals to 15. Open up the bracket, 2x plus 1 plus 2x squared plus x plus 3x squared equals to 15. Okay, we arrange it to a quadratic equation. We'll get 5x squared plus 3x minus 14 equals to 0. Factorize this, we'll get 5x minus 7, x plus 2 equals to 0. And here we'll get x is equals to 7 over 5. X is equals to minus 2. Okay, after we get x, we sub into equation 1 to find y. Okay, so here we sub x into 1. Y will be equals to 2 times 7 over 5 plus 1. This one y is 2 times negative 2 plus 1. Okay, 7 over 5, we will get 19 over 5. Here we will get minus 3. Okay, so it doesn't matter which one is A, which one is B. Okay, you just select lah. Okay, up to you. Let's call this, okay, let's put the smaller one as A. Okay, so I put A minus 2 minus 3. B positive 7 over 5, 19 over 5. Okay, but it doesn't matter, the A and B. All right, so this is the first part. After we have done the first part, we are gonna find perpendicular bisector. Okay, perpendicular bisector, we need midpoint, we need gradient, we put into y minus y1 equals to mx minus x1. Okay, let's find what is the midpoint first. Okay, midpoint of AB. So we take x1 plus x2 divided by 2. Minus 2 plus 7 over 5 divided by 2. Then 19 over 5 minus 3 over 2. Okay, here, we will get minus 3 over 10, 4 over 10. Okay, correct? These values, minus 3 over 10, 4 over 10. Okay, sorry. Let's simplify this. This one will be 2 over 5. 2 over 5. Okay, the next one, we want to find the gradient. Okay, gradient of AB first. So M AB, which is y2 minus y1 over x2 minus x1. So here will be 19 over 5 minus 3 over 7 over 5 minus 2. Okay, here we'll get 2. Okay, I just put it in the calculator. Then gradient of normal, we'll take the negative reciprocal. So here will be negative 1 over 2. Okay, the next one. Equation of perpendicular bisector. Equation of perpendicular. Okay, I just write perpendicular B. So we'll use y minus y1 equals to mx minus x1. We have to use the gradient of the normal and the value of the midpoint. So y minus 2 over 5 equals to minus 1 over 2 x plus 3 over 10. Okay, from here, it is not necessary for you to simplify, but if you want to simplify, also it's fine. Okay, normally if you see in the mark scheme, they will just leave it in like that. Okay, y minus y1 equals to mx minus x1. Okay, but if you want to go and put into y equals mx plus c, also no issue. Okay, after we find the equation of the perpendicular bisector, now we want to sub in these two values. Okay, so we're going to sub in when x equals to 21 over 10 and y is equals to k. Okay, so here we will sub 21 over 10 k into the equation. Okay, equation of the normal perpendicular bisector. So here will become k minus 2 over 5 equals to negative 1 over 10, 21 over 10 plus 3 over 10. Okay, go and simplify this entire thing. So 21 over 10 plus 3 over 10 times 1 over 2, we'll get negative 6 over 5. Okay, then k, negative 6 over 5 plus 2 over 5. Wait a minute. Did I do something wrong? Minus 6 over 5 plus 2 over 5. Negative 4 over 5. Okay. I think it's a pretty easy question. Yeah, gotta be careful, okay, when you all do all the steps here. Okay, because if you wrong the first part, let's say you're A or B, very hard for you to check also. So you make sure double check, triple check it. Okay, for question B, I realize a lot of students will get stuck. Okay, what formula did you all use for this? The point D lies on the perpendicular bisector of AB, such that its perpendicular distance from AB is twice that of the point C from AB. Find the possible coordinates of D. Okay, anyone use length formula over here and then got stuck? Yes, okay, use length. Use length. Okay, can use length or not? Okay, can we use length formula over here? Okay, this one is actually more simple than using length. The easier way to do it is yours do a rough sketch out to see the diagram. Okay, so let's say we got these two values. So like this. Okay, let's say we got A and B here. Okay, I just roughly estimate. Okay, so A is -2, -3. B is 7/5, 19/5. Okay, the midpoint, what's the midpoint? -3/10, 2/5. Okay, what are they asking over here? Or what are they stating over here? They are saying that there's a point C. Okay, where's the point C? Okay, point C is this 21/10K. Okay, what's this point C? 21/10 minus 4/5 is on the perpendicular bisector. Okay, then they say point D is twice the length of point C from AB itself. Okay, you try your best to sketch out properly where exactly is the point C. Okay, so if I were to sketch it out, it probably looks something like this. Okay, point C. So this is the midpoint. Okay, point C is probably around, let me see, -4/5. Okay, probably around here lah. Oops. Okay, around here. Okay, I'm just doing a rough estimate. Point C. Okay, it is 21/10 negative. This is -4/5. Okay, -4/5. Okay, I will draw a little bit bigger so that we can see clearly. Okay, I'm not drawing to scale, so we see this part here. Okay, this is -3/10, 2/5. Okay, they ask you to find the possible coordinates of D based on this. How do we do this? They say midpoint, okay, that means the perpendicular length, which means from the midpoint. Midpoint to D is twice the length of this. Where can D be at? Okay, you look at this diagram, twice the length means D can be over here or over here. Got it? Okay, either the top or the bottom. Okay, I gotta draw a little bit bigger for this. Okay, like this. All right, everyone understand the statement here? Okay, D can be here or here. Either one of the part here, on top or the bottom. Then it fulfills the statement. Perpendicular distance from AB is twice that of the point C from AB. Okay, we are not going to use length formula over here. For this part here, we are sort of using vectors. Okay, but actually it's just counting your X and Y. How to do this? I want you all to calculate the distance, the X distance from here to here first. Okay, so what is the distance from -3/10 to 21/10? Okay, so we take our calculator, we take 21/10 minus 3/10. Okay, so plus 3 over 10. Plus 3 over 10. Okay, we will get 12 over 5. Okay, you all see the distance here? Okay, let me try to... Okay, the x distance is 12 over 5. Then when it goes down here, so you see from 2 over 5 to negative 4 over 5. So negative 4 over 5 minus 2 over 5. So this will be y is negative 6 over 5. Okay, we just write here lah, 6 over 5 like that. Okay, so going to the right and going down. Okay, everyone can see how it looks like. So how do we calculate the distance? Twice the distance. So that means this one same thing also. You'll go right, then go down. Same amount of distance. 12 over 5. Then here, another 6 over 5 go down. Okay, we calculate for this point D1 first. Okay, how do we do point D1? Okay, let's write it in a vector form, a column vector form. So minus 3 over 10. Here we need to plus 2 times 12 over 5. Okay, here you see 12 over 5, 12 over 5. For the y value, we'll take 2 over 5 plus 2. Okay, since it's going down, it's minus 6 over 5. Okay, can you see the calculation? So calculate this plus 2 times 12 over 5. Okay, over here will be 9 over 2. Okay, 9 over 2. And the bottom here, 2 over 5 plus 2 times minus 6 over 5. We'll get minus 2. Okay, we will write it in coordinate form. So 9 over 2, negative 2. Okay, so this is based on the first one at the bottom. Okay, the second one, we'll do the same thing. Now it's like that. Okay, so going to the left, like that, left, like that. Okay, so 2 times the distance. We'll do the same thing. So going left, going up, going left, going up. Okay, what is the distance? Just now was the x is 12 over 5. Okay, so here now is minus 12 over 5. You go to the left. So minus 12 over 5. Going up, now is positive 6 over 5. Here also, positive 6 over 5. Okay, so now we will put this into the formula again. Okay, so minus 3 over 10 plus 2. Okay, the x is minus 12 over 5 right now. Okay, the y is 2 over 5 plus 2 positive 6 over 5 since it's going up. Okay, calculate both of this. Minus 3 over 10 plus 2 times minus 12 over 5. We get minus 51 over 10. 2 over 5 plus 2 times 6 over 5. Okay, here will be 14 over 5. So the second answer will be minus 51 over 10, 14 over 5. You want to write it in decimal place also, it's fine. Okay, question 8. If you are good, can you type 8? You have seen this in the past year question, right? Okay, one of the past year paper. So you all have done enough. This is a question that has come up before. Okay, can you just type 8? Can we use length formula? Cannot. Okay, for this. Because if you use length formula, you will get two unknowns, x and y. So we won't be able to solve the question. So initially, you may think use length formula. Okay, so just sketch it out. Then you can get the answer here already. Okay, let's go to the next one. Question 9. This is on vector geometry. The diagram shows the trapezium OABC. Okay, they gave us all these values here. AD to DB is 2 to 1. Okay, let's write down this ratio. Normally, ratio, I will write it like this. Okay, I put it in a circle. 2 to 1. The point X is the point of intersection of the line OD and AC. It is given AX is lambda AC, OX is mu OD. Okay, what is AB? Let's find A to B first. We can go this direction. So AB will be AO plus OC plus CB. Okay, we refer to the diagram. So here will be minus 4A plus C plus 2A. Okay, we will get here minus 2A plus C. Okay, or C minus 2A. Okay, next one, OD. Okay, where is OD? Here to here. Okay, we can use OA plus AD. Okay, from here we already got minus 2A plus C. Okay, so let's label this down first so we can see. This is whole thing minus 2A plus C. Okay, I want to use OA plus AD. OA plus AD. AD is 2 parts out of these 3 parts. So 2 over 3 of AB. OA, 2 over 3 of AB. Okay, AB from the previous question. So OA is 4A plus 2 over 3 minus 2A plus C. Okay, go and calculate this. You will get here 8 over 3A plus 2 over 3C. Okay, the next one. OX in terms of AC and mu. They gave us in the question here, OX is mu OD. We just found OD, so we write down OX is mu OD, mu 8 over 3A plus 2 over 3C, which will get 8 over 3 mu A plus 2 over 3 mu C. Okay, then next one, AX in terms of AC and lambda, we have learned, we have given to us AX equals to lambda AC. What is AC? Okay, let's look into the diagram and get AC or not. AO plus OC. Okay, AO plus OC. So AX equals to lambda AC, AO plus OC. Okay, by the way, all this naming is not necessary for you all to write. You want to write straight to the final answer, or you just substitute in the value, it's totally fine also. Okay, so here lambda minus 4A plus C, and we are here get negative 4 lambda A plus lambda C. Okay, the final one. Hence, find the value of lambda and mu. So we need to, normally, whatever they give us for the lambda and mu, we need to equate both to a same vector. Okay, so here got OX, here got AX. Okay, what we can do is you can go and find what is OX, or you can find what is AX, depending. Okay, you go see lah, based on the diagram. Okay, based on here, can we find OX based on lambda? Okay, I think can, right? We can do OA plus AX. So OX, OA plus AX. Okay, we want in terms of lambda first. So here will become 4A plus negative 4 lambda A plus lambda C. Okay, we simplify it. Oh, sorry, we group it together. So here will be 4 minus 4 lambda A plus lambda C. Next part, you got 2OX. Okay, so we equate both OX value. Okay, we look from the previous one. Here got negative 4 lambda plus lambda C. Then this one here. Okay, 4 minus 4 lambda A plus lambda C. We're going to equate this with this, C with C. Hey, sorry, is it lambda? Sorry. See, I also blur already. We need to equate with this. OX. So not this negative 4 lambda. Okay, this value. Okay, so 8 over 3 mu A plus 2 over 3 mu C. Okay, is it correct? 4 minus 4 lambda plus lambda C. Yeah. Okay, so these two we equate with each other. Okay, we take the A first. So you just equate the coefficient. A is 8 over 3 mu equals to 4 minus 4 lambda. Okay, depending how you want to equate it. C 2 over 3 mu equals to lambda. Okay, I'm going to substitute the lambda. Okay, going to substitute 2 into 1. Eight over 3 mu equals to 4 minus 4, 2 over 3 mu. Okay, solve for this. This will be 4 times 2 over 3. 4 minus 8 over 3 mu. 8 over 3 times 2. Okay, this will be 16 over 3 mu equals to 4. 4 times 3 over 16. We'll get mu equals to 3 over 4. Okay, then here, we're going to sub this value into here. Sub mu into 2. So 2 lambda equals to 2 over 3, 3 over 4. Lambda will be equals to 1 over 2. Okay, these two will be your answer. Okay, number 9. If you can do this, can you type 9 in the chat? Okay, no questions? All very good, Okay, here. Okay, let's go to the next one. Question 10. Solve the equation 7 tangent square theta plus 5 tangent theta minus 2 equals to 0 from minus 80 to 180. This is a 4-mark question. Okay, this one definitely will be in paper 2 lah. Okay, first one. We have to identify that this is a quadratic equation. So you can simplify it first if you want to let tangent theta equals to, let's say, m. Okay, so 7m squared plus 5m minus 2 equals to 0. Okay, factorize this first. 7m minus 2, m plus 1 equals to 0. M equals to 2 over 7. m equals to -1. Okay, then we change it back. Tangent theta equals to 2 over 7 and tangent theta equals to -1. Okay, we're going to solve it. This is in terms of degrees, so make sure you change it to degree mode on your calculator first. Okay, how to do this? We find what is our base angle. Alpha is inverse tangent 2 over 7, which will get 15.9 degrees. Okay, this is a positive tangent. So positive tangent, we will take ASTC. T, where will T be at? Okay, we'll take first quadrant and third quadrant. Okay, look at the angle that is given to us here also. Okay, if you know how to find it, that means it will be like this. Okay, from negative 180 to 180. Okay, if you don't know how to do, you'll find normal 0 to 360 degrees first, then you minus it off. Okay, but since this is an easy one, you should know how to find it, which is here. Okay, from negative 180 to 180. This part here is 0 to negative 180. So to calculate this angle at the bottom, this is like how you calculate second quadrant like that. 180 minus alpha, then you times negative in front. This one will just be alpha. Okay, so final answer here will be theta equals to 15.9 degrees. Theta is minus 180 minus 15.9 degrees. Okay, which we'll get here minus 164.1 degrees. Going to the negative side. Okay, once again, if you don't know how to do, you will take your normal, how you calculate your ASTC, then you minus 360 degrees to both the answer. Then your final answer, you see which one is within the range. Okay, so this one is a little bit longer. You'll get 4 answers, then you have to reject 2 answers. Okay, this one, -1. So -1 alpha, our base angle will be equals to 45 degrees. Okay, which quadrant will it be at? This one is ASTC. Okay, second and fourth quadrant. Okay, because tangent is negative. So second and fourth quadrant. Okay, this one will be negative alpha. Here will be 180 minus alpha. Okay, so the theta will be, do the positive one, 180 minus 45, which is 135 degrees. Then here, minus 135 degrees. Okay, so a total, you will have 4 answers here. 1, 2, 3, 4. Okay, wait a minute. This is negative 45. Minus 45 degrees. Okay, if you feel your working is a little bit too messy, okay, you find some space at the bottom right. You write down all your answer. Okay, your theta, you write from smallest to biggest lah. Okay, minus 164.1 degrees, minus 45 degrees, 15.9 degrees, and 135 degrees. Okay, you need all 4 answers over here. Okay, question D. Solve the equation of this from 0, 5 to 3. Okay, the symbol is called phi, is just another angle symbol, where phi is in radians. Okay, so change your calculator to radian mode first. Okay, what do we need to do here? Okay, you solve as normal. So 3, okay, we rearrange first. So sine 3, 5 minus 1.5 is equals to 2 over 3. Okay, then here we find our base angle inverse sine 2 over 3. Okay, inverse sine 2 over 3, we will get here 0. Okay, hold on a minute. Inverse sine 2 over 3. Okay, you see, I didn't put the close bracket, then the answer is totally different already. 0.730. Okay, this is our base angle. Now, how do we calculate the angles, or what is the range of the angles that we want? So now the angle that we are solving is 3 phi minus 1.5. The domain that's given to us in the question is from 0 to 3 only. So we need to convert to this part here. Okay, so now what's the next step that we do? Okay, so I'm gonna do this at the side here. Okay, so here is 0, phi to 3. 3 phi. Okay, we get here, we multiply it by 3. This one will become 9. 3 phi minus 1.5. Okay, this one you minus 1.5 to all the values. We will get here from minus 1.5 to 7.5. Okay, so that means the domain of values that we want is from negative 1.5 to 7.5. Okay, if you want to draw it out clearly, how do we do this? For me personally, I will change it to degree first. Okay, so I will calculate it in terms of degree. So we'll do 1.5 times 180 divided by pi. Okay, this is negative 85 degrees. Okay, to 7.5 times 180 divided by pi. Is it correct? 7.5. We want to change to degree, right? 7.5 times 180 divided by pi. 429.7 degrees. Okay. So where are we considering from? From one quadrant at the bottom. Okay, this is just a rough estimate. Where's our starting place? Is from here. Okay, negative 85 is around here. Right? 429.7 is around. You go one round is 360, then plus another 60. So until here, somewhere here lah. But we don't have to do it until like this. Okay, we just want to have a rough estimate first. Okay, so where is the angle that we want? Sine is 0.73. Okay, let's say you don't care about this domain first. This one is actually not necessary to do. Okay, the way to do lah, you find out all the values first. So 0.73 here. Okay, what is the angle that we want? Your first quadrant, 0.73 times 180 is around 41 degrees. So, okay, I'll erase this pink color line. I think it's a bit, maybe it will distract you all. Okay, this one is here, AS. Okay, so here is alpha pi minus alpha. Okay, to calculate it. So now we're going to do here 3 phi minus 1.5. You will have two answers here. Okay, what is alpha is 0.730. Pi minus alpha. Okay, we type pi minus 0.73. We'll get 2.41. Okay, 2.41 here. Okay, what are we going to do with these two values? Because there is one that is at the negative, one is at the positive. So let's say we don't know, okay? We don't know which is which. I want you to just type in your calculator, both the values, you just plus and minus 2 pi to all of it. Okay, so I want you all to do maybe minus 2 pi first. Okay, so you do here minus 2 pi. So 0.73 minus 2 pi. Okay, this one I put in green color. Minus 5.55, 2.41 minus 2 pi minus 3.87. Okay, then we do another one plus 2 pi. Okay, plus 2 pi. 0.73 plus 2 pi, 7.01, 2.41 plus 2 pi, 8.69. Okay, from all of these values, you see which one is within this domain. All the others, you have to cancel it off. You don't go and waste your time calculate it. So we want from negative 1.5 to 7.5 only. Okay, these two, you see, this one out. 7.01, okay, this one is acceptable. This one is out. So we will only take these three values here. Okay, to calculate for this. Okay, so I will rewrite it again. The one that we want is 3.5 minus 1.5, 0.730, 2.41, and 7.01. Okay, you got these three answers here. Now, all the values, we want to find what is phi. So we will take all the values plus 1.5 divided by 3. Okay, then divide by 3. Okay, go and do this for all the three values. We will get here a point plus 1.5. Then divide by 3. Okay, 0.73. We'll get 0.743. 2.41. We'll get 1.30. Then 7.01. We'll get 2.84. Okay, do you all get these three values? Okay, what if we miss one of the values? Minus 1 mark. So I think most of you all probably will miss this one, right? 7.01. So if you miss this one, you minus 1 mark. The final answer, you'll get 3 marks already. Yeah, so you have to check. Okay, you have to check based on the domain here. If you don't know based on the graph, like for this, I think the easier way, you just minus 2 pi because we want to get the negative side. Then you plus 2 pi also. Plus 2 pi means you go one more extra round. One more extra round like that. Okay, question 10. If you can do this, can you type 10? Okay, Ze asks, if we come across similar question, we just take minus 2 pi and plus 2 pi to all. Yeah. Yeah, you have to see the domain. So if got negative, you go your ASTC first. Okay, so whether it's 2 answer or sometimes it may be 4 answer, if you got both plus and minus, you take whatever answer that you have. If you see the bigger value is more than 360 degrees or more than 2 pi, then you add 2 pi, depending how many rounds that you will go. If you see a negative value, you take all your answer, you minus 2 pi. Then all the answer that is like out of the domain that you calculated, you reject it. This is in a way a longer way to do it. So the previous question, you can do the same thing also. But the previous question, because the number is quite nice, so I know like which quadrant will it be at already. So you can also do this. You find, like let's say this one, you find the first and third quadrant based on ASTC 0 to 360 degrees. Then you minus 360 degrees because of the domain. The domain is until negative 180. Then you see whatever that is out of the domain, you reject it. Anything that's out of negative 180 to 180. Okay, answer your question? Mr. Ze. Yes, okay. Any more question? Yeah, 100% trigonometry, a question like this will come up. Okay, whether paper one or paper two. I think maybe paper one okay, not highly unlikely, but probably won't be so hard. Okay, because paper one, most likely they will only test you on questions maybe on your special angles or 0, 90, 180, 270, 360. Okay, this one you confirm need calculator. Okay, let's go to the last question before we wrap up. The first three terms of arithmetic progression. Okay, is here the sum to the n terms giving an answer in the form log x3 where k is in terms of n. Okay, if you don't know the formula, go and refer back to the front. It will be given to you. Okay, so what do we need for sum of n terms? We need two terms, which is our a and our d. A we already have, which is the first term. Let's find out what is the d value. Okay, we need to simplify here first. D, we can take second term divided by first term. Sorry, minus, not divide. This is arithmetic. So we can take log x81 minus log x3. Okay, how do we simplify this? We can take 81 divided by 3. X81 divided by 3, which is log x 27. Okay, log x27, you can simplify it if you want. Okay, you can write it to 3 cubed 3 log x3, because you see, later on the final answer, you need some sort of log x3. Okay, we're going to put into the formula, sum of n terms is equals to n over 2, 2a plus n minus 1 d. Okay, we're going to substitute this inside. N over 2, 2 log x3 plus n minus 1 times 3 log x3. Okay, this I think is a pretty easy question. 3 marks only. Okay, can we simplify inside? Okay, we factorize out the log x3 first. Okay, n over 2 log x3. Here will be left with 2 plus n minus 1 times 3. N over 2 log x3. Okay, so 2 minus 3 will be minus 1. So this will be 3n minus 1. Okay, they want it in the log x3 behind. So we just rearrange it. N over 2, 3n minus 1 log x 3. Okay, they say k is in terms of n. Okay, k is in terms of n. So this can be our k value. K is n over 2, 3n minus 1. Again, not necessary for you to write this down, but it's up to you. You want to open up the bracket, also can. This is k. Okay, the last question. Okay, the last question. The first three terms of a geometric progression are 1, 3 tangent square theta, 9 tangent to the power of 4 theta. For 0, theta to pi over 2. Find the values of theta for which this geometric progression has a sum to infinity. Okay, so sum to infinity, what is the equation? Okay, the condition is modulus r is less than 1 or minus 1. Okay, look in the question. More than, less than 1, right? Oops. How come this one disappear? Oh no. Okay, less than 1. Oh no. Okay, okay, jam already. Give me a moment. I think too many files inside. Okay, less than 1. Okay, so we write down the condition. Every time when we do sum to infinity, you refer to this one. This is the value of sum to infinity. The condition is this over here. Okay, now how do we expand this? We'll make it like that. -1 to +1. Okay, what is R first? Let's calculate what's the R value. R, we'll take second term divided by first term, which will be 3 tangent square theta over 1, which is 3 tangent square theta. Okay, we're going to solve for this. 3 tangent square theta less than -1 to 1. Okay, we have to know this. Tangent square theta. Okay, can we solve tangent square theta from here for -1? Got such thing or not? Okay. If don't know, don't worry. We just solve it as it is first. So we divide by 3, both sides. So tangent square theta less than 1/3 to 1/3. Okay. From here, what do we do? Okay, from here, what do we do? So how does a tangent theta, okay, we need to find tangent theta. One more. We square root both sides. Okay, but you see here, this one you cannot square root it, right? So there'll be a math error. So what we're going to do, because we cannot square root, the negative part we're going to reject. So based on the tangent graph, if you all see your tangent graph, okay, means we want to go from 0 onwards, because the smallest value right now, we cannot take a negative 1/3 since it's mathematically not able to. So we change it to tangent theta square root. Okay, we square root both sides. Here will be 1/, square root 3. Here we'll take it as 0. Okay, so we'll start at 0 over here. Okay, everyone understand until this part? Okay, so now let's look back into a tangent graph. Okay, how does a tangent graph looks like? This one is our 90 degrees. Okay, 90 degrees is pi over 2. This one negative pi over 2. Okay, where exactly is this tangent theta from 1 to from 0 to 1 over cert 3? Okay, we'll probably take this part here only. Okay, and then to be more specific, okay, we put shift tangent 1 over cert 3. Shift tangent 1 over cert 3. Okay, we'll get pi over 6. So I want you all to solve for this one here. Theta is equals to inverse tangent 1 over cert 3, okay, which is pi over 6. Okay, where is pi over 6? Probably somewhere in the middle here lah. Okay, we don't know where is it, but we just roughly estimate. Okay, so that means the value that we want is until here. Okay, so here is your y is equals to 1 over cert 3. Remember, we don't take the negatives part here because of the square. Okay, we cannot square root it, so we need to take from here onwards. Unless here it was tangent theta negative 1/3 to 1/3, then we can solve it with inverse tangent 1/3. But because here, math error, so we just consider from 0. Okay, so here is pi over 6. So our final answer will be from 0 to pi over 6. This will be the domain of our answers for theta. Okay, if you go see your paper 1 and paper 2, the variant 1 and variant 2 for this October-November series, the last question, all of it is quite similar. They also give something like this, a series, and then a Trigo question like that. You'll just draw it out. All right, question 11. If all of you are good here, can you type 11 for this last question? Okay, any question, please ask me. How do you know 1 root 3 is pi over 6? I type in the calculator. Inverse tangent 1 over sec 3. Just type this in the calculator. Can you do without calculator? Can. But you have to draw out all your special angles. You have to do your special angles. You have to write it all out. Because pi over 6 is how much? 180 divided by 6 is 30 degrees, right? So you will get this specific value, 1 over sec 3, okay, in the calculator. Sorry, in the special angle. But I think, I don't want to confidently say, but I think this one maybe won't really come out in paper 1. You all just get ready lah. But this, like, they give you the values, and you need to roughly know all the special angle values also. There'll be like some 1 over sec 3, sec 3. So you need to roughly know that it's from 30 degrees, 45 degrees, and 60 degrees. And this applies for your mathematics also. Okay, so someone was asking me, okay, do we need to know special angles for maths for Trigo? Answer is yes. If you all saw from the February-March 2025 paper. All right, okay, this is it. We'll stop here. Okay, and then we have one last final paper to go.